All right. If you didn't get finished up with the bell work, that's okay, as long as you have it submitted by the end of the day today. So we have that D lunchtime where you can get it finished up. Just kind of pause where you're at for right now, because I want to make sure that we get through the lesson stuff. In your books, page 41 is where we're going to be today. And we're going to talk about basically the same thing that we did yesterday. We're still going to be graphing lines. But now these lines are going to be my boundaries between two half planes. A plane is just a flat space. And we're going to be using these lines to draw a boundary so that we're cutting one side from the other. And we're going to shade one side. We're going to be working with inequalities. I want to make sure that everybody can graph the lines with us. If you do not have a straight edge near you, raise your hand. I didn't have a bunch of people were out earlier today in my fourth period class. You've got one, there's one for you. Who else needs a straight edge? Do you have one? Okay. Does everybody have a straight edge now? Have lots to choose from. So we can use the same three techniques that we learned yesterday. What were the three techniques that we talked about for graphing lines yesterday? We can make a table, like the first question of the bell work today. You can make a table, plot those points, and connect them. You could find the X and Y intercepts, plot those 2 points, and then connect them. Or what was the third option, the third way we talked about? Put it in slope-intercept form. So we're going to have rise over run and our y-intercept. So those are the three methods that we talked about yesterday. The biggest difference between yesterday and today is after we know where those points should go, after we know what our line looks like, is it going to be a solid line that's called a closed boundary, or is it going to be dashed? Does anybody remember from Algebra 1 how you decide whether it should be closed, solid line, or open, dashed line? Yes, Ibrahim.
I think it's like, the thing, the greater than logo got a line under it or not.
Yes, that's exactly right. So when we've got greater than and less than, alligators are eating one way or the other. If it's just the greater than or less than, we use a dashed line. It's an open boundary. If it has that little or equal to line underneath it, that's when we're going to draw a solid line. All right? So far, so good? Then we're going to have to decide which side to shade on, and we'll do that using a test point. We're going to check whether we should shade above or below by picking out some point that is not on that line. Why would it be important for me to not pick out a point that's already on that line if I'm trying to figure out where to shade? If I was trying to figure out which side of the fence to paint, and so I stood on top of one of the posts, would that help me figure out whether to shade this side or that side? No. I have to be clearly on one side or on the other side of the boundary if I'm trying to figure out which side I'm going to paint. So I don't want to pick anything that is exactly on my line. My favorite one to pick, because it is the absolute easiest, is the origin. Because what's the ordered pair for the origin?
0, 0.
0, 0. So when I go to test that one, I put 0 in for x, I put 0 in for y, and I can multiply by 0 in my head. The only time I can't use 0, 0 is when? I said you're not allowed to pick points that are where? That are on this line. If this line were going through my origin, that's the only time I would have to pick something different. And I'll show you guys how to test other points too, just in case that comes up. We're going to watch a real quick video. go.
To graph a linear inequality in two variables, begin by graphing the boundary.
Go away.
Use a solid line for an inequality that includes a less than or equal to, or a greater than or equal to symbol. Use a dashed line for an inequality that includes a less than or a greater than symbol. Next, use a test point to determine which half plane should be shaded. Selecting 0, 0 as a test point often makes calculations easier. Then, shade the half plane that contains the solution set. If the test point makes the inequality true, shade the half plane that contains the test point. If the test point makes the inequality false, shade the other half plane. To check your solution, identify a point in the solution region. Substitute its coordinates into the inequality to check that it makes the inequality true.
All right, so that is what we're going to practice doing. We are going to be on example number 4 that's on page 41. Page 41. So here is the inequality that they've given us to work with. We need to use one of our 3 methods. Are you guys okay if we practice putting this into slope-intercept form and graphing it from there? All right. So that's what I want to do first. I have 12 minus 4y is greater than x. Slope-intercept form has which piece all by itself? Yeah. Wonderful. I want to get y equals mx plus b. And it's okay that this isn't an equal sign. I'm still going to treat it kind of like it's an equal sign as I work through these operations. So first I need to identify where y is, because that's the thing I need to get alone. Y is right here, correct? Is there anything, as I'm looking on either side of this, that is either being added or subtracted around here? Yeah. I've got this 12 out here. I see the minus sign after the 12, but I use those pluses and minuses as like dividing lines. Is this 12 a positive or a negative?
Positive.
How do I make something that's positive cancel? Subtract it. So I'm going to subtract 12 from both sides, which means I've got what remaining on the left-hand side now? 4y. That's almost correct. What did I forget? The negative. Don't forget to bring that minus down. Is greater than, and then I have x minus 12. It's not going to be a negative 12x because we said we were subtracting. So I still have to show subtraction here. So we've got negative 4y is greater than x minus 12. Is my y all by itself?
Yeah.
Almost. There's no more pluses and minuses, right?
Yeah.
But there's still a number that is stuck next to y. What operation is sticking that number next to y? Multiplication. It is the only operation that is allowed to be invisible. Whenever you see a number stuck next to a letter, it's multiplication happening there. How can I make that cancel? Divide. I'm going to divide both sides by negative 4. That means I divide both pieces over here. So it cancels out. Something really interesting happens here, though. Whenever I divide by a negative, it's going to flip my inequality. So it's not going to be a greater than anymore. I have to flip this around, and it looks like this now. There's a little invisible number next to my x. What is the invisible number next to the x? 1. I have a 1x right here. And down on the bottom I have a negative 4, right? If I divide those, I have negative 1 over 4, and then I put the x next to it. So negative 1 over 4. And then over here, that was a minus 12, right? If I take a minus 12 or a negative 12 and I divide that by a negative 4, what type of number will I end up with? Positive. It's going to be a positive what?
3.
Positive 3. All right. So make sure you fill in your blanks with the missing pieces. And I also want you guys to underline and circle these pieces. We divided by a negative, which did what to my inequality symbol? What did I say we had to do to the alligator mouth when we divided by a negative? We had to flip it. We had to reverse it or flip it. That is only if we multiply or divide by a negative. If I add and subtract, my inequality stays the same. If I multiply or divide by a positive number, nothing changes about my inequality. It's only if I multiply or divide by a negative. If I multiply or divide by a negative, that's when my inequality is going to flip. Gentlemen, please make sure your phones are put away. We're doing this for right now. We'll have time for that later. All right. So my boundary line is y equals negative 4x plus 3. The inequality has to do with where I'm shading, but my boundary line is y equals negative 1/4 x plus 3. So y equals negative 1/4 x plus 3. Which piece of that is the first point that I should graph? 3. That's my y-intercept. That's my b value. Let's go plot that one on our graph. Right here. What is my slope? What is m? Negative 1/4. Here's my slope. What does the numerator of the slope tell me? Yes, that's my vertical shift. That's my rise. It says I'm going to rise negative. Which way am I going if I'm rising negative? Down. If you see a negative number in your numerator, we're going to go down. Or if there's just a negative sign out in front of our fraction, we're going to go down. This is rise over run. So from that first point that I plotted, 3 on the y-axis, I'm going to go down 1. And I'm going to run which way? Should I run left or should I run right? We're going to run to the right. 1, 2, 3, 4. You need at least 2 points to graph this. I've got 2 points on there, so I could grab my straight edge. Could I get another point on here if I wanted to? Yeah, I can't go down 1 and right 4 again, or I've run off my graph, but what could I do? Yeah, I can do everything in reverse. 1, 2, 3, 4. And run this way, and I could get another point here. More points makes for a more precise line. I'm going to sketch it in. Do I draw a solid line or should it be dashed? How do I decide? Where do I look to make this decision? I'm looking at my inequality. Does it have that or equal to underneath it? Does it have a little line? If it doesn't have a little line, then I don't draw a solid line. It's going to be dashed. It is open. We say that the boundary is open or dashed line. So grab your straight edge. We're going to draw a dashed line in here. Should I have arrows on the ends of this? Could it keep going if the graph was bigger? We need some arrows on the ends of this. All right. How are we doing with getting the line on there? Give me a real quick thumbs up, middle, down. Just putting the line on. Okay. Am I finished? No. I still need to figure out what? What do we still need to do with inequalities? Other than solid or dashed, we're going to need to shade one side. The part that we shade means if I pick out any of those ordered pairs and I substitute them in, it would be true, it would work. So we're going to pick out a test point. For me, dear? Does anybody remember from the first part of class, my favorite test point is which ordered pair?
0, 0.
0, 0. Why do I like that one so much again? It's easy. It is literally the easiest point I could pick out. So back into the original inequality, I'm going all the way back to the problem that they gave me. 12 minus 4y is greater than x. And I'm going to substitute in 0 in the place of the y and 0 in the place of the x. What's 4 times 0? 0. So this really says 12 minus nothing, which is what? Yeah. Not nothing. I'm going to have 12. 12 minus nothing. 12 take away nothing. I'm left still with 12. Yep. And on the other side, I still just had a 0. Is 12 actually greater than 0? Is that true or false? Is 12 bigger than, greater than 0? Yeah. So that is true. Now I'm going to come over here to my graph. Where's the point that we tested again? 0, 0. Here's my test point. And we said that this was true or false when we substituted it in and we simplified. Did we get something that was true or false? True. If my test point is true, we will shade that side. So I'm going to get my highlighter out here. I'm going to shade that side of my line. If we test our point and we get back something that's true, I shade that side. If I test that point and I get something that's false, like 0 is greater than 5. 0 is not bigger than 5, is it? If I get a false statement, then I don't shade that side, but I still need to shade. So which side would I shade if I see something false? Yes. If we test our point and it's false, then I shade the other side of it. We can check to make sure that we've shaded the correct side, even after we've done our shading. You want to pick out some other point there. They've picked out 4, 1. Is that in the region that we said was supposed to be shaded?
Yeah.
So when I substitute this in, it should come out to be true. Which number am I going to put in the place of the x?
4.
4. So where I see the x, I'm going to replace it with a 4. And what am I putting in the place of the y? 1. So where I see the y, I'm going to put in a 1. What is 4 times 1?
4.
So I have 12 minus 4. What is 12 minus 4?
3. Hold on, 3. 8.
8.
Oh.
It's okay. On the other side, I still just have that 4 that I'm going to bring down. Is 8 greater than, bigger than 4?
Yeah.
Yeah. That is true, which means it should be shaded. Is it in the space that's shaded? Yes. Then I know for a fact that I shaded the right spot. I mentioned this already, but tell me again, why do I not want to pick out a point that is right on that boundary line? Close. That is one of my reasons. What am I using my test points for again? I want to know which side I should shade. If I pick out a point that's on the line, will that let me know whether I should shade over here or over here? No. If it's a solid line, the points on that line would be solutions. I would get true things back, but that doesn't help me figure out whether I should shade this way or that way. So that's why I don't want to pick out points that are on that boundary. How about one more example for us, and then we'll call it a day? Sound like a plan? Okay. You doing okay, Trent? Or we're asleep? Head up for me, dear. Okay. What's my original inequality? What did they give us to work with? Yes. 9 plus 3y is less than or equal to 8x. How is that or equal to going to change things? It's going to be solid instead of dashed. If it has a little line, then I draw a solid line. If it does not have a little line, then I dash it. So I know right from the beginning that it is going to be a solid line, which they call a closed boundary. You guys okay if we put this one in slope-intercept form like we did with the other one? Okay. That's the most common way we're going to see these when we graph or when I ask you to graph lines, is putting it in slope-intercept form. Which piece do I want to get alone if I've got it, or if I want to put it in slope-intercept form? Y. Is there anything right next to the y? Yeah, I've got a 3 right here. I have to treat this as one unit together for right now. I have to get rid of any pluses or minuses. I can't touch the 3 because the 3 is not being added to the y. It's not 3 plus y. So what do I need to get rid of? 9. Is that 9 a positive or a negative? How do I make something positive cancel? Subtract it. So I'm going to subtract 9 from both sides. So I have 3y is less than or equal to 8x minus 9. Is my y all alone? Are there any pluses or minuses around the y anymore? So how do I get rid of the 3? Divide. Right now it's being multiplied, and I need to divide to get rid of that. If you do it to one side, got to do it to the other side. What do I do it to on the other side? Anything and everything I see on the other side. So I have to divide the 8 by 3, and I have to divide the 9 by 3, both pieces. If I grab my calculator and I do 8 divided by 3, does that come out as a nice, whole, pretty number? No. Comes out as a decimal. I don't want to try to graph decimals, so I'm just going to leave that as the fraction 8 over 3. The x goes next to it. What about if I do a -9 or a -9 divided by 3? Does that come out pretty? Yeah, what would I get? -3 minus 3. Why didn't I flip my inequality? We didn't divide by a negative. This is a positive number, no flipping. Only if it's a negative do we flip. Which piece of this do I want to graph first? Y-intercept. Which one is the y-intercept here? -3 is my y-intercept. So I'm going to plot that point right here. What is the slope? Yes. 8 over 3 is my rise over run. So we're going to go up 8, and we're going to go to the right 3. So 1, 2, 3, 4, 5, 6, 7, 8. Up 8. And to the right, 1, 2, 3. So here's my point. Can I fit another point on the graph that they gave me to work with?
Yeah.
Can I fit more than those 2 points on there? Where could I put the other point? How would I even get another point? I'm not saying that it's not possible to graph it, but how would I find where it goes? What would I need to do again? I could flip them. If it was possible, I could go up 8 again and over 3, but that takes me off the graph they gave me, right? So I could do everything in reverse. I could go 1, 2, 3, and then down 8, but what's my problem? It goes off the graph on the other way. I can only fit 2 points on here. Do I want to do a solid line with my straight edge or a dashed line this time? Why? There's a line underneath, and so I draw a solid line. Yes, sir?
You can't go to the left 3 and then go up 8.
No, you would have to do both parts in reverse. Good question. If I'm going to go backwards, everything is backwards. That is a great, great comment. Thank you. All right, so I'm going to connect my dots to get my line. I don't need to worry about it being a dashed line this time. Should I put arrows on the ends of it? Yes. So we graphed our line. We decided solid or dashed, but the graphing of the line is just like yesterday. What do I still need to figure out because it's an inequality? What side to shade? Should I pick out the y-intercept to test? Should we test this point right here? Why not? Because it's on my line. I don't want to pick out points that are on my line to test. I want to test things that are clearly on one side or the other. My favorite test point is which one? origin. As long as it's not on my line, it's a good one to test. So I'm going to put 0 in for y and 0 in for x. What should go right here? I did my substituting. I put 0 in the place of the x. I put 0 in the place of the y. What should this be up here? 9. I need to bring this 9 down. And now I need to simplify over here. What's 3 times 0? So I have 9 plus 0, which is what? 9. Over here, 8 times 0? 0. Is 9 smaller than, less than 0? No. It is not smaller than. So we would say this is false. So now when I put my test point in, we got back something that was not true. So do I shade there? Where do I shade then? Other side. Do not shade over here because it is false. So we have to shade the opposite side then. So I'm going to shade here. What about if I'm not feeling super confident that that was the right answer? I'm not 100% sure that I shaded correctly. What can I do to make sure that that is actually shaded correctly? Pick a point that's on that side in the shaded space. So they've gone ahead and picked out a point for us. Let's test this one right here. What's that ordered pair? 3, 1. Which piece goes in for x? The 3. So in the place of the x, I'm going to put a 3. What is 8 times 3? 24. And then what are we putting in the place of y? 1. So where I see the y, I'm going to put a 1 in. What is 3 times 1? So I have 9 plus 3, which is what? 12. 12 is less than, or 12 is equal to 24. Are either of those statements true?
Yes.
Yes. Then that means that this whole thing is true. Which means it should be shaded. Is that dot in the space that we shaded? Then we shaded the correct side. That's how we know for sure. You guys about ready to wrap up for today? Cool. Skip that guy. Homework, the 1-5 is due tomorrow. If you did not finish up the bell work yet, if you haven't submitted that 3-question bell work, start with that. 1-5 homework is due tomorrow. There is one minor change on the homework that's in McGraw-Hill versus what's in your book, and it's on problem 27. You just need to flip the inequality. I don't know why they did it one way on the computer and one way in your book, but we're going to make your book match what's on the computer. Okay? Yes. Huh? Homework that was due, there was homework due yesterday, the 1-4, but there was no homework due today because 1-5 was a 2-day lesson. We had graphing lines and inequalities, and we took a day on each and one homework assignment for that. Yep.